so 313 is called trigonometry and polar coordinates. The concept here is not terrible. This is basically taking coordinate points and learning how to plot them on a polar coordinate grid, which you are going to use for the next 3 sections, which is the end of your content, right? Once we get to 315, you're done with your AP content. And then learning how to convert between what's called rectangular and polar, okay? It is a simple concept, and yet if you don't understand today's, you cannot build upon it. This is the building blocks of the next 2 sections. So it's super important that we grasp anything. So if you have a question today, you need to ask it so that we make sure that we really have a foundation built on this to build into the next couple sections. So first of all, there are 2 different kind of there are 2 different planes we're going to learn about today, and the first is the complex plane. A complex plane, if you think about complex numbers involve imaginary numbers, okay? So a complex plane has an imaginary axis. The x-axis is your real axis, you're just like normal. This doesn't change, okay? But your y-axis now becomes an imaginary axis. And if you look at the plotted points on your imaginary axis, they all have an I on them because I is your imaginary number, okay? So all we do is we take a coordinate point, or it will be written in a sum or difference point, something like 3 minus 4i, for example, and we plot that as though it was 3 comma negative 4, because the 3 is the real part, so I would go to the right 3, and then negative 4, I'd go down 4, and that point, minus 4i. Looks just like a regular point. Okay, you just have to know that if that's reversed, if it said negative 4i plus 3, I always know the one with the I comes second. So that's my vertical axis. So yep. You don't do a comma, you just do it. Yeah, you just plot it that way, but you treat it as though it was like a comma. All right, so 2 minus 3i is to the right, 2 down 3. That would be A. And B, negative 3 plus 4i, I go left 3 and up 4. Easy stuff, right? Yeah? Okay. I went right 2, down 3, plot a point, and I went left 3, up 4, plot a point. Yeah. All right, so again, this is your polar coordinate plane, okay? Right, it is your unit circle, just extend it out. The coordinate points are going to given to you in this way. So the first number represents a radius. The second number represents it's called a directed angle, but it's the angle, okay? There are most of the time that angle theta will have a pi on it. So it would say something like 2 and pi over 6. Most of the time it's pretty obvious, okay? But it could also say 2, 0, and be in polar coordinate point form, okay? So the second part is your angle. The first part is the ring you go to on that angle. So I go second part first. If it said 2 pi over 6, I'm going to locate pi over 6. We know that's in the top right corner. And then I simply go to the second ring, 1, 2, along that angle, and that would be 2 pi over 6. So if it said 3... 5 pi over 6. I'm going to find 5 pi over 6. 5 pi over 6 is over here in the second quadrant. And I would go to the third ring. And I plot a point. Not bad, right? Okay. This is the foundation of what we're going to eventually make these roses and limicons and circles and all these weird shapes. But you have to understand that those points are what make it up. So you have to be able to plot those points, okay? The other thing is that it could give it to you. So let's say you had a negative angle. We know how to plot these, right? Like if it said 2 negative pi over 6. Where is negative pi over 6? I go to 11 pi over 6, right? Go to pi over 6, flip it down, and it's here. And go to 2. This would be 2 negative pi over 6, okay? We know how to do that. What we haven't done yet is if there's a negative on the R. If there's a negative on the R, then instead of going towards the angle, you go the opposite way. So I would say pi over 6 is same spot we started with, so that pi over 6 is there. But instead of going towards pi over 6, I go along its opposite ray, which would be 7 pi over 6, and I go 2 out on that side. So if the R is negative, we go the opposite direction. You go away from the angle that you would normally go towards. Still good? Yes. Okay. So let's say it said 2, 0, and you don't know if that's in polar coordinate form or rectangular form, because it could be that too. Where would you plot 2, 0 on a rectangular coordinate grid? If it was just x and y, where would 2, 0 be? On the x-axis? Second spot, yes? What if this was polar? Where is 0? On the right. And where would 2 be? Same exact spot. Okay? So if it's on a quadrant angle, so 0, pi over 2, pi, 3 pi over 2, that point would directly overlap with a rectangular coordinate point. Does that make sense? Okay. All right, so let's plot these points. You do, plot all those points, and then I'll check back in. Plot and label. All right, so 3, 11 pi over 6. I'm going to go to 11 pi over 6, which is here. Go to the third ring. That would be number 1. Okay, negative 3, 11 pi over 6. Instead of going towards 11 pi over 6, I'm going the opposite direction, which would be 5 pi over 6. This would be number 2. 2, 2 pi over 3. 2 pi over 3 is in the second quadrant. Go to that second ring. That's 3. And 4, 3 pi over 2, 4. I'm going to go down. Oh, those are terrible colors, but do you see them? Yes? Questions so far? Okay, now it's going to ask you on WebAssign to find additional names for those same points. On a multiple choice or AP style question, this could be, which of the following would be the same coordinate point as blank? And it will give you your original r theta. So let's say my original r theta, I'll keep going back to 2 and pi over 6. Let's say it's originally that, okay? And I wanted an additional way to say the same name, or additional way to say the same angle. So here is that point, right? If I add and subtract 2 pi, what happens? What's the relationship between angles if you add and or coordinate points or whatever, if you add and subtract 2 pi? What are they called? They would say the same. They're called coterminal angles, right? So if I add 2 pi, it's going to come all the way around that way. If I subtract 2 pi, it's going to come all the way around that way, but it still ends up with the same point. So if it wants an additional representation of the same point, that is one way to do it. Keep r by itself. So leave r as it is. So it would be like 2. Add 2 pi. If I wanted to add 2 pi to this, it would be 12 pi over 6. So 13 pi over 6 would be the same point. Or I could subtract 2 pi from this, and I would also get 2, God bless you, negative 11 pi over 6. Those would be the same point if I plot those. You with me so far? Okay, but then another way to find it, so you'll see on your homework, it's going to ask you to find something between 0 and 2 pi. And both of these would not work because 13 pi over 6 is too big and negative pi over 6 is too small. So if I wanted it to be between 0 and 2 pi, the other way to find it is go halfway around. So go the opposite direction, change my r to be a negative r. So if I changed it to negative 2, if I change it to negative 2, I would be over here. How would I get it to there? Or this way. I'm going half a circle. So I would be adding or subtracting pi. So your other option is change the sign on the r. So I would make it like negative 2. And then add or subtract pi. So pi over 6 plus pi would be 6 pi over 6, 7 pi over 6. And that angle would fall between 0 and 2 pi. If you think about what this looks like, right? If it's negative 2, 7 pi over 6, 7 pi over 6 is here. Instead of going towards it, I go away from it, and it's the same point. So when you're looking for additional representations of the same angle, those are your options. Keep r as it is, add and subtract 2 pi, or change the sign on your r, add and subtract pi. Make sense? Yeah? All right. Now we're going to go from polar to rectangular, or polar to complex, and rectangular to polar, or complex to complex to polar, okay? So we're converting back and forth between the two. The first one is polar to complex. So if I have r theta and I want to go to complex, this is in a plus bi form. Then I take my r, I multiply it times the cosine of that angle, and I add to it r times the sine of that angle. So if I had 2 pi over 6, I'm going to keep going back to the same one. Then that is that's polar. And if I want to get into complex, I would do 2 cosine pi over 6 plus 2 sine pi over 6. And I add the I on to make it complex. And then what's my coordinate point at pi over 6? Square root 3 over 2 and 1/2. So this would be 2 times square root 3 over 2 plus 2 times 1/2. And I keep the I because that's what makes it complex. And I'd get root 3 plus I. If I overlapped a complex plane on top of a polar coordinate plane and I plot those points, they should overlap. They would be exactly the same. If it asks for it in rectangular form, then I just don't do the I. It would be r cosine theta, comma, r sine theta. So rectangular's inside parentheses because it's an x, comma, y. And complex is with a sum or difference with the I on it. So a plus bi. But the process is exactly the same. So if I wanted this in rectangular, it would be square root 3, comma 1. All of those are the same point. Good so far? Okay. All right, so we're going rectangular. This is already in polar. So this is my r, this is my theta. It would be 2 cosine pi, comma 2 sine pi. And at pi, which is on the left, my coordinate point is -1, 0. So 2, the cosine there is -1, comma 2, the sine there is 0. And my coordinate point would be -2, 0. If you think about plotting this, right, if I go pi, I know on a polar coordinate plane, pi is over here. I'd go to the second ring, and those points should overlap. So quadrant angles, you don't really have to go through the whole process of converting because you can also eyeball it, but that is how it would be done. If it asks for this in complex form, let's say, then this would just be -2. There would be, or it could write plus 0i, but highly unlikely it's going to write that. It would just be -2. It is not in coordinate point form. Okay, that's the difference. All right, B, again, to rectangular, this would be square root 3 cosine pi over 6, comma, square root 3 sine pi over 6. What's the coordinate point at pi over 6? Root 3 over 2.5. So this is root 3 times root 3 over 2, comma, root 3 times 1/2. Root 3 times root 3 is 3, and root 3 over 2. And if it wanted it in complex form, it would be 3 over 2 plus root 3 over 2i. You can always kind of plot it, like estimate it and plot it, at least see if you're in the right quadrant. That's an easy check. Questions on that one? Okay, so now I'll go back to the second part of this. The second part of this is complex rectangular to polar. This is not hard, but it gets a little weird, so if you're not paying attention to me, you need to stop doing whatever that is and listen, okay? So if we are going from rectangular or complex, and we want to put it in polar, so the end answer is an r comma theta situation, okay? Then there are two parts. The first part is you have to figure out r, and r is the square root of x squared plus y squared. If it's in complex form, it's the same thing as the square root of a squared plus b squared. Those are the same. That gives you the r. And then theta is going to be found using tangent because we have the y and the x. The y would be your opposite. The x would be the adjacent, right? So it is found by doing tan -1 of y over x or tan -1 of b over a if it was in complex form. Now for every single tangent, there are two answers. For every tangent being root 3 over 3, there's 2 answers. For every tangent being -1, there's 2 answers, okay? But only one of them is right. And this is what's important because it could totally, you lose all the points by doing one stupid thing, okay? And it is figuring out where the angle is initially. So take that coordinate point, figure out what quadrant it's in. If I had, so if I'm going to work backwards from this one, if I had square root 3, comma 1, what quadrant is that in? First quadrant. So I know when I go to pick my tangents of theta, I'm only picking from the first quadrant. Technically, all of those answers also happen in the third. But I know because my initial point is in the first quadrant that that's the angle I need to pick. So then I would get r by doing the square root of square root 3 plus 1 each squared, which is 3 plus 1 square root 4, which is 2. That's my r. And then my theta would be tan of theta equals 1 over root 3, because it's y over x. And then tan -1 of 1 over root 3. I don't need you to go through the work of it, but what would that be rationalized? That's root 3 over 3. Where is root 3 over 3 an answer for tangent? At pi over 6. It's also at 7 pi over 6, but because we said we're taking it from the first quadrant because that's where that angle is, or that initial point is, then that's how I know which one to pick. So my answer would be 2 pi over 6. So you have to know where to pick it. To be honest, a lot of times I plot it at the very beginning to remind myself where it is. And then it eliminates the possibility of there actually even being a second one because I know which quadrant I'm looking at. All right. Example 4. A, convert point 2, 2 to polar coordinates. So I'm going to do A with you and then I'll let you do B and C together. So first of all, where is 2, 2? First quadrant. So r equals the square root of x squared plus y squared, square root of 4 plus 4, square root of 8, which is 2 root 2. And then tan of theta equals 2 over 2. Tan of theta is 1. So where in my first quadrant is tangent? 1. Pi over 4. So 2 root 2, comma, pi over 4 is my polar coordinate. All right, you do B. So where is -1, 0? Start there. It's actually on my x-axis on the left-hand side. Do you even have to go through all the conversion process? No. What is your r? 1. What is your theta? Let's say you went through the conversion process because you're going to have to know how to do it. R would equal the square root of -1 squared plus 0 squared, square root of 1, which is 1. And tan of theta would equal 0 over -1. Tan is 0 on the left-hand side at pi. Okay, then C is in a complex form. If the complex form throws you off, rewrite it. This would be -3, -3. You don't need the I on it when you go to convert it. So square root of -3 squared plus -3 squared is the square root of 9 plus 9 squared 18, and that's 3 root 2. That's your R. -3 is back and left, which means, or left and down, sorry, which means it's in the third quadrant. And then tan of theta is -3 over -3. Tan of theta is 1 in the third quadrant at what angle? 5 pi over 4. So 3 root 2, comma 5 pi over 4. Questions? Overall, not terrible, right? Okay.